chat's still working. Test chat. I think it is. Okay. Set it on. Okay, so welcome to Audulus Office Hours live stream. You're probably going to watch this on a video on demand on YouTube. It's 5 in the morning here in Croatia, where I live, and what I'm doing here is I'm creating 2 sets of libraries. One of them is for the DSP node, and the other one is for the Canvas node into Audulus. And there's the Canvas node. The Canvas node lets you draw things, and the DSP node is a way to process information in Audulus. And one thing that we've been lacking for a while since we've introduced these is a really thorough, expansive library of code that you can use. So right now, instead of having to, every single time you want to you make something, you do it from total scratch. What I'm doing now for the DSP library is I'm working on the oscillator section, the oscillator class, because what you're doing here is I'm going to explain a lot of things that maybe will be a little over your head if you're completely new to programming, but eventually I'm going to really try to break these things down so that even a total beginner to programming could understand what's going on here. And essentially, you can just ignore all of this code up here is the code that I'm using and the code that I'm writing, and then underneath here is where we're actually writing whatever's going to go on in here. In the DSP node, you have to define a function called process, and it inside of this process function is what actually happens and gets input and output of the node. Right here, I'm creating a new oscillator by calling the os.new method, and it's assigning it to this variable right here. And then I'm adding that to this update queue of everything that needs to be updated at every sample. And then within this process, you have 2 areas. One, this area right here. This area happens every frame, which is the frames variable here that gets passed to the process function. That is the buffer size. So if we go into the settings, here it's 512. And so every 512 samples, you are doing this update logic here. So for example, let me explain this first actually. So there's this once per frame. So this happens less often. And because we can put things that are control signal related in here, things that don't need to be updated every single sample. That means that we can do fewer calculations and fewer variable assignments, and it saves on CPU, which can be really helpful in bigger patches. So what I'm doing in every frame is updating the hertz value from this knob, updating the phase offset from this knob, updating the sync, which is, you can have this to reset the waveform. This trigger right here, I'm pressing the button. And then the shape knob here, so shape, changing the shape of these waves. And then inside of your process function, you can have a for loop that will loop over every sample that's coming in. Basically, you get to define these inputs and outputs here. Inputs and outputs. And these become, inside of here, they become arrays that they accumulate the last frame's worth of, or the current frame's worth of samples. And you have to iterate through them to change them. So first what I'm doing here is calling this util.update, and here we have this small little helper function. And what you do is you pass an array to this util.update function, And then for each object in this array, it calls the update method for that object. So right now we just have an oscillator that's doing every sample, so update every sample. There could be a update, every frame, but I don't need to do that right this moment, so I don't have that there. Like I could, just do every frame, and then I put something else in here, right? And then I would call the util.update every frame like that. So then it could happen twice with this one function here, but now I'm updating this collection every frame, and then this collection every sample, right? But right now you don't need that. So when we go to the oscillator has this update function here, and what that's essentially doing is setting the current phase of the oscillator, which itself is calling this function from the phaser, and we're continually updating the phase of this phaser that's going from 0, like down here, to 2 pi. And from that 0 to 2 pi value from the phaser, we're deriving all of these waveforms. And that's how we're getting all these. And oops. We are updating the oscillator, so updating the phase of that oscillator. And then we call these different methods here on the oscillator to output different waveforms. And what's cool is, so this one oscillator has one like phaser core of it, and it's exactly analogous to this, and I'll show you here. So the VCO. This is the node version. Oops. So go in here. We have different wave shapes, right? And if we go in, we'll look at the VCO core inside of there. And what we have here is you have the hertz value coming into the phaser, right? The phaser is like here, the phaser class. And this object actually creates a new instance of this object. So when you create this os.new, you are actually also creating this phaser, this internal phaser here, right? And that phaser feeds all of these wave shapers right here, and then they get mixed, or actually, they're kind of not mixed; they're selected between here. And if we go inside, you see it at each wave has its own shaping logic. So this is for the saw, and this creates a super saw copy of it. And then here's the triangle. So this takes the phaser, the 0 to 2 pi value in. Let's see the wave value. I'm actually going to back out here real quick just to illustrate this, because that's going to go really quickly. Root, and then I'm going to attach a -10 here. That's to slow the waveform down. So now you will see here. What was I? I was in the triangle. Yep. So it goes from 0 to 2 pi, which is 6 point, whatever. So you see it going up there. Now we're shaping the wave here and creating a triangle. And then this is the shape section. We're applying a kind of overdrive with a hypertangent and fading between these two. So this is the unaffected triangle, and this is the affected triangle. So you essentially get the point here that this is what we're taking the phaser input, we're shaping it to create the shape, and then we're further shaping it to have a kind of extra shape control, and then mixing between the two. And we're doing that also in the code here that allows us to do the same thing, where you can see the triangle here, and I'll slow it down so you can see the shape a little better. So there's the triangle, and then doing the shape. And now you might notice that it's not a perfect triangle here, and there's a reason for that. If I go down here, and I can actually call raw triangle. Oh, did I have raw? Maybe I didn't. Okay, you'll see this. 1 sec. What I do is I have all these different files that I keep this code in, and then I have a little shell script that's here. And what all of this does is it takes all of these files and it smushes them together into one file that I can then copy and paste into here. So all I do is for my terminal down here in VS Code, I press up and then enter, and then it does the same command again. I copy and paste that, or copy that, paste it, and now I should be able to do the raw triangle. No, why isn't it working? Oh, there it is. Oh, I must have the scaling off. Okay. What did I do there? Okay, let's see me fix this in real time. Raw triangle. So the math is off for this. Let me, for the sake of explaining this, I'll do raw sine. That'll work right there. See? So raw sine doesn't. It skips over all of this. You can see how there's less logic in here, fewer calculations that are happening, and that's on purpose so that if you have an instance in your own uses, but when you're using the library, you just need a sine wave, and you don't need to have a shape control over it, then you have a less computationally expensive sine wave to make here. So when I change the shape knob here, you can see it doesn't change here. It does, however, respond to the phase changes. You can see that. That's the phase offset. And that's important because if we want to do, a phase modulation, like a DX7 type of synthesizer, we still need to have access to the phase modulation, which is easy because that is just happening in the oscillator.update method here. Right? Okay, so where was I? I was explaining. So what I'm doing now is might as well just dive into the coding part. I'm going to fix this triangle, this raw triangle, because I didn't realize there was a problem with triangle. So it's a scaling problem, and just a tool I want to make. Now I should make that one today. Yeah, I think I will. Basically a high-low detector, and this will help me. It helps you with scaling issues a lot. Or I'm realizing, okay, this is probably, it looks like it's peaking at some point here along 1, but it's going down to like -pi or something probably. Just looks odd. Okay, so I'm going to compare these two functions. The raw triangle, this looks, okay, so I should just be able to copy and paste this into this. Is that the same? Okay. I realize I'm doing some odd calculations here, but okay. Now I have to go into some of the areas where I'm reasoning about stuff, so I'm going to go up into this file. I like to work over in VS Code because then it's saving my changes, and sometimes maybe I'll forget to paste them back and forth. I like the syntax highlighting in VS Code more, but here it's also useful to directly manipulate things when you need to. Okay, raw triangle. I'm going to span this out a little bit. Okay. Triangle. Oh, I is this what it is? I think maybe I forgot to put a parentheses around these two. Is that it? There, yeah, well, that's better, but okay. Yeah, because what I was trying to do there, what I was trying to do here is shift the phase so that they're in phase, so I don't need that. There we go. Okay, yeah, that's what it was, because I would need to do the rescaling. So what I had been, what's good about these pure waves, you can see how these aren't matched up in their phase. So if I reset them, they're not resetting from the same point. The triangle is starting down here, and it's going up, whereas the sine is starting from directly in the middle, so at 0. What I wanted to do for like the basic, when you call sine, right, that the user experience, the developer experience, I should say, is that the sine, the triangle, the square, and the saw are all synced together in phase. So if you do triangle, here you can see now they're locked in phase with one another because this is a different triangle. However, it's also, you can see how it's a little bit shaped, which is the point I was trying to make before. And that's because it is a part of the shaping, this, you know, and I'm realizing now as I'm saying this, I can probably get around this somehow, yeah, by mixing. No, but that's the thing, see, yeah, I did this. I'll show you the difference in the methods here. So, in this method, it'll be easier to show you here on this larger waveform. -10. Okay, let's do -8. Yeah, 9. Okay, so I am going to do the wave shape triangle. Okay. Now, this is the shape control, right? You can see it responds. This is super saw, overdrive, and pulse width that's going on the VCO. And if I set it to triangle, it has an overdrive function. And as I increase the overdrive, I'm actually going to do this back down to -10 because it's a little easier to see. What I'm doing here is I'm actually mixing between an overdriven version and the clean version. And so when I'm doing this, you're still getting that peak there. You can see how it's coming to a peak up here. And as we get more overdriven, it's overdriving it more, but you still have that peak, right? And this is, it's unique, it's interesting, it's not something how it's usually done in like an analog circuit where it's all you would do is feed the triangle to a kind of amplifier and just overdrive it, and you would get saturation and until we eventually get to a square wave almost. The way that this shape works is it's currently going through the overdrive circuit and then the overdrive expression. And as we do it, it's a much smoother transition. It's almost a sine wave, right? And then at this point, you're getting, especially like halfway, you're getting what almost like in a lot of circuits, this would be the sine wave that you would get. You would get a sine wave that look a little like this, that has a little more character than just a pure sine wave. And I wanted to, when I was making this DSP library, to change that behavior from how it works in the VCO module to work differently here. If I maybe put them on top of each other, you can see, I'll do like here. So you can see that difference there. There's no peak here and a little peak here. Okay. So what was next on my to-do list? Put this in. Okay, I forgot to put on Do Not Disturb just in case I get any Do Not Disturb. Okay. What am I doing next? So I made all of these. Saw face. Ah, yes, I was working on the saw. this works, right? Wait, this works. Oh no, oh, it was the phase. No, it isn't. The phase is working. Yes, I wanted to create a high-low detector because it looked like, this looks like it's actually exceeding -1 to 1, which maybe that's fine if it's just a tiny bit for the library, but I would like to somehow scale this. Oh, actually, I realize now what I wanted to go back to with the triangle. See, I gotta put little to-dos in here. If I'm about to do this right now, so to do mix from pure triangle to overdrive. Wait, no, but I can't do that, I don't think. Yeah, no, that's the problem. That I talked myself out of it as I was doing it. You can't mix from the triangle, the pure triangle, to the overdrive triangle in any way without losing that very smooth transition from the sharp triangle to the smooth triangle. But down here, what are we doing? We are we have to create a high-low detector. Ensure the 1-to-1 range. So I'm gonna make this utility. I'm gonna split. No, I'll just pull this up. So now, what do I want to do? I want to do this high-low detector. See, for this, I need to make an object, I think, because it needs to hold state. Or I could do a closure. But if I did a closure, I don't know how to reset it after. I don't think you can. Yeah, or it would be convoluted way too. So I'm going to create a new file. Yeah, because utilities, I just want to have like little helper functions. This one is an actual, like, maybe I can make a detector class. I think a detector class. Let's try detector. Here called probe detector. This is like a, yeah, maybe debug. No, do detector, that's right, because you could have legitimate uses of this outside of. So I'm kind of mumbling to myself a little bit, but what I'm going to make here is a high-low detector. So it's going to take a signal in, and I'm going to, for example, on this saw wave, figure out just how much it's exceeding the signal range. Because if I just put a, where is it? A value node here, I can't really tell, like it's probably, it's flashing a tiny bit a 1 there, which probably means that it's shooting over just a little bit. But I want to know exactly how much it's shooting over by, and then that will be able to, I'll be able to guide my design choices that way. So first I'm going to make a new class. Split this right, and I always just look at another class to kind of set it up. So we do a detector equals an empty table. I do a shortcut like this. This shortcut is only just used when you're writing code within this this library here. Like I always use this when I'm calling on other things like phaser.new, even though I could just do p.new like this. Okay, that's the same thing. But that's just added there for convenience. So detector index equals set up the constructor here. And I just copy and paste this line. And always change this. Right, because I don't want it to point to that. What I'm doing here is I'm setting up a constructor that will return an object that is a member of this detector class, and the detector will hold some methods that the class will be able to operate on itself, but I want this object to be able to store some state internally that I can manipulate. So, for example, yeah, because I want to make this, you know, you have to think ahead about these things, and I want to be able to set and reset values inside of this detector. For right now, we'll instead of trying to think ahead to like all the use cases and make it generalized, I'm just going to do it for just this one. So high-low. Self dot high equals 0. Self dot low. Let's do actually. Yeah. I don't want to nil check later. So do low and high first, like that. Okay. So then I'm doing a method detector dot high low. And I'm gonna do the X, right? Because it can just be whatever signal that's coming in. And for this, I think I actually need a sample and hold object. Now I'm thinking about it. Okay, this is one of those where I can maybe copy and paste this. I'm gonna do in input, and then the output on here is going to be high and like low, high. Okay, I'm gonna attach these two. You can imagine this is going to be like the high-low detector here itself, and let's do the sign just first. Okay, and we'll get rid of these just because they're a little distracting. And turn the shape down. Okay. So now I'm going to go down here and get rid of this code. Let's do update every sample. Okay. Okay. All right. So what I need to do is every sample, I need to grab the value at the input, and then if the value is, so this is that value, the value at the input, if that value is greater than the stored value, then I'm going to store it. If not, yeah, okay. There we go. Yeah, we need to reset. So, reset. Now, here's one of those things that I'm trying to syncs the oscillator to resets it, even though they're essentially the same thing. I need to instantiate a self.negate. What this one is. It's used internally. This double underscore means that it's sort of not meant to be accessed outside of the object. It's just internal, for internal use only. Yeah, so that reset is going to come in here. Okay, let me just open this panel, the phaser. I have to remember what I was doing with the, the sync. Or sync is great, yeah, because then sync comes in here. And, whoops, oscillate. Yeah, I'm passing that self gate to pulse. That's what it is. What should I call that? This is one of the harder parts of creating libraries, thinking of variable names. Basically, I have this reset signal that's coming in. I want that to be gate, so let's just call it gate. And then reset, local reset equals self dot gate to pulse. I created this helper before I started streaming. What it does is it takes incoming gate and it turns it into a pulse. So do that self dot reset. Yeah, okay, so right, yeah. Is that right? Self dot sync. Okay, so yeah, self dot. Equals 0. I'm initializing these values here. So self dot whoops, sync. Okay, I have to use the restroom. I'll be right back. So BRB. I'm out of coffee, but I'll just suffer from now. Okay. What we're doing here, we were gonna back up real quickly in here and just see. Okay, I was just doing the sync from. Okay. And we need a sync reset, a reset here, because we don't want it just to be forever stuck at the low and high. We want to be able to zero them out so that they go back to zero. Okay, detector. So if reset, we can close these out. If reset, then self.low, self.low equals 0, high equals 0. So we're gonna grab the gate comes in here, and we assign it to this gate. Yeah. Wait, no. I'm confused. Hold on. So, no. We don't need this because we were calling this self.sync, right? Oops. Sync. Right. Detector. Okay. Should we be able to bind this to a signal? No. Yeah, okay. So the detector is keeping track of this internal state here. We have the low and the high, and the sync value, this will go up, and then internally we convert that sync signal into a reset pulse. So if reset, then we're going to set these low, self.low and self.high to 0. And then else. We're going to, okay, so if x is less than self.low, then self.low equals x. Else if x is greater than self.high, it's only going to be one or the other, then self.high equals x. That should work, right? Let me see. Okay, so okay, and then we'll make, this is the high-low detector, right? And then we want to do we want to return immediately from this thing? I think so. So return low, high. Self.low, yep, of course. This, if you're new to object-oriented programming, this is self.low refers to this particular instance of this detector object. So like when you create a new object, it has its own set of these variables, and so the self is just saying point to this one rather than some kind of global variable or a shared variable between all of the instances. So I'm going to return both of these values from the high-low detector. Let's try this. I don't know if this will work the first time. Sometimes. Okay. Now we'll initiate or initialize. So equals detector think I need an update method on this because it's just gonna output immediately right there. So, right, I think so. Okay, so output low equals whoops. I equals D high low, and we'll do input I. Okay, so that didn't work. 217 near in. Oh, did I think I did do input. Yeah, because I think that's a reserved keyword. Yes, yes, it is. Okay, so in simple. Let's do that. Forgot about that. It's in simple. Okay. Right now I do this. So detector d dot sync equals sync 1, and we just want to grab the first frame out of this frames that it's sending and send that to the sync. Obviously it's not working yet. Okay. High low, the in sample. So let's do a debug output. Debug I equals. Okay. Let's just make sure, for sanity's sake, in sample I. Okay, good. So it is coming in correctly. Oh wait, oh of course. Of course. I forgot. Okay, this happens sometimes. Okay, this is in Python, zeros are truthy false, or falsy, and their ones are truthy. So in Lua, it's a little different. This I have to actually explicitly check for this. If reset equals 1. Because otherwise, if reset is 0, zero is still truthy to Lua. So that's why that's happening. There we go. There we go. Perfect. You see how the... There we go. Excellent, excellent. Okay, there's our high-low detector. Don't need this debug anymore. Debug there. And why not? Let's just make this a little module for right now. Because I could of course be putting it in here and then making like separate debug outputs, but that's a little finicky, and I just want to have like a separate little module that I can just probe into here. So I'm going to actually put this whole thing in its own module, and I do group, and go into here. Let's expand this a little bit since we're working in Audulus. Okay, do this. Actually, let's just do input. Do utilities text. High, low, and high. exposed. These are exposed. That's exposed naturally. Okay. Reset. I always like to put the kind of first input at 0, 0. So we'll do expose position 0. And let's do a sync or something. Let's just do S then. Okay. Or reset. Reset, whatever. Who cares? Let's just delete this thing. We don't need the, whoops. We know what that does. Low, high. Let's turn on the grid here, make it a little nicer. Okay. Where's the turn on and off the edit mode? I forget that was it. It's E. Yeah, E. Okay. It's been a while since I've actually not been using the modules very much. I've been in the code land, so I'm rusty on the shortcuts. But of course we need to. This is gonna. If the numbers are longer, then they'll. Yeah, let's do this. Zoom in and do that. Here, okay. There we go. Nice little high-low detector. Maybe we don't even need the in there, that's a little distracting. It's implied that that's the input. Okay. So let's do this from the saw. We were having that problem with the saw before. So 1 to 1, good. But now the shape, see, yeah, it's going up by a little bit more. This is the problem that I was trying to solve before. Figure out exactly how much it's going up by. If it's just going up by a constant amount, then that's good. Right, because if it's just, if there's no shape, right, so then it's 0, 0, but the shape is actually introducing some extra value there, all the way up to 12. Okay, and actually, let's think about this. So maybe halfway is the biggest point, right? Because this is just sort of, okay. So I think I could actually account for that and be constantly, essentially as you're turning it up, it would be making the wave smaller by this factor up until the middle and then let it go back up again for this size to keep it between -1 and 1. Okay, go back to code mode, save, always want to save. This is a good little module. Okay. Okay, so we'll go back to oscillator, and I'll go down to this. I did the high-low detector. Ensure 1 to 1 range. What am I doing here with this phase shifted thing? Was I just tripping on? I didn't need to. I also need to do operations. I think I'm. No, that one's for the triangle. I think the triangle's got an extra step in it there. Yeah. Something about 2 pi, half pi, one of these things. Maybe. I'll think about that later. Okay, so as the shape knob goes up, we want to reduce it by a constant amount to 0.5. Not a constant amount, but a growing amount. So, okay. So we'll go separate this logic out a little bit. So, or multiply it by, okay, so if it's let's make sure these are also high precision. Now that I think about that, okay. I used to be able to get more precision from the value knobs, but the value nodes, but now we're stuck with this only for. Not stuck. I think Dale will bring it back. He just hasn't got around to it. Because in cases like this, I don't know if this 0 is the last 0. Is it the last 0? Like it's just 1.125. Because if that's the case, then here I can actually change this update. Do it a lot quicker as I go through the middle here. Yeah. You can also set it directly. Why is this in European values? 0.5. Does that work? Did you use the comma? Really? Okay. Something happened where I set my computer into like Croatian and stuff, and then it wants to use the comma now for points. That's the way they do it here. Okay. Yeah, because I don't know if this is like a 0, 1. Because if this is 1, 2, 5, then that actually seems like something I could just account for in the math. Like something's happening here to generate that. Now, okay, so I'm just going to do it's a reduction factor. I'm going to test something real quick. I'll just test my math here. So times, that would be 0. That's 125. That's 875, right? Times 0.875. Let's try that. What am I doing wrong there? Okay. Am I doing that calculation wrong? I'm trying to see what at the peak, the factor by which I'd have to reduce it. Is it 975? No. I'm confused. Hold on. Okay, interesting. Now this switched from being that to that. Okay. we'll just treat it like, because I did do that, and 7.5. That's gonna keep it between. This is weird. 6, 7. 8. So I do want to keep it as close to 1 as possible for the high and the low. 9. Yeah, see that's over. I don't want that. 8. Okay, well, that's the 8. 8 is our magic number. So factor equals R factor equals. Okay, so we have to do this whole thing. There's also this other translation math we have to do, where you want it to go up to 0.88 and then down afterwards. I have to remember how to do that. It's like a kind of a center indexed knob, almost. Trying to remember. Okay, 0. Because with the shape knob, it's the selfish shape. That's the knob that's being turned. And I think this is one of those absolute value moments where yeah, I could start at -1. So times 2 minus 1, right? This gets the self-dot shape moving in a 0 to 1 range. And then I want to take the math.absolute value of that, and then I want to invert that over the plane, so that will create the triangle. So because if you have the self-dot shape, that's a knob that's going up from 0 to 1. I should get a little program here where I can draw. What is that thing called? It's like, what's the app where you can draw? Well, let's ask ChatGPT. I forget what it's called. Is it Sketch? Is it just called Draw now? Draw? No, there's a thing on. Move back at sketching. I forget what that's called. Oh, you're Googling it for me. Here's what I discovered. Sketch. Is it just called Sketch? Sketch. Oh, okay. I don't know. Preview. Yeah. Forget it. Okay. But essentially, you have a 0 down here and a 1 up here, and then we're going from 0 to 1 as we're turning the knob, but then I want to lower that so that it's negative and go to a positive, and then you'll make an inverted V like this when you do absolute value of that. Then we have to flip that inverted V around to do this, where it goes up and down. That's what this does. And then what it does times 0.88, so that sets the maximum of that. And we will then yes, multiply this by the R factor, so that by R factor. R for reduction. I'll find up a better name for that in a second. Okay, so now we're doing it way too much. Way too much. Oh, whoops. Oh, okay. I did that wrong. Oh. Yeah, 1 plus. Right? No. I tried to divide it by R factor? Hold on. Is that right? Okay, yeah, okay, that's the idea, but it's too strong. Weird. Okay, so odd. Does that make sense? Let's try. What does this do? I'm not super great with math, so I'm having a hard time visualizing what's going on in my head. Why just that? I took away the 0.8. Oh, I'm so stupid. I left it in over here. There we go. Okay. So it's being reduced to half there. I don't want that. What am I doing wrong here? Okay. See, to debug this, to get that value out of the R factor, I'd have to like kind of assign it to the, return it separately. Yeah, I could do that. 1 plus 1 minus. I really need to sketch this. There's some drawing app. What is it called? Can I just do it in notes? Pages? I'm gonna open up Pages. That seems like overkill. Yeah, I guess. Where was that? I think notes you can. Okay. Okay. Can I draw? I feel like you can draw in the add sketch. There we go. Okay. Oh, I can touch my phone. Interesting. Okay. So, doing this on my phone. Okay, so that's going from there to there. 0 to 1. 0 to 1. You can't see what I'm doing right here just now, but I will promise next stream I'll have some kind of app for this. So 0 to 1, and then I want to do -1, and then so 1 to 1. Okay. Let's do that. So, okay, so you see this, there's that, what I was talking about, the 0 to 1, this is a little dotted line right there. And then we have a dotted line here, and then negative 1 to 1. That's the times 2 here. Self times shape. This is self shape times 2 would go from there to 2, but then we shift it down 1. We go to negative 1. Now, the next step would be to, where was that? Add add sketch. Okay. So, add the sketch. Then, with the negative 1, we want it to take the absolute value. So then we create this inverted V, I think, and then we want to shift that V, right? Before we do this, we want to do this. Okay, I think I have it. So times, yeah, because I want to, you're making this V, and then you want to reduce its shape before you invert it. So 0.8 right there. Okay, I think that might be it. Nope. Yeah, diddly. Okay. Doing divided by to do multiply by. Maybe that's it. No, that's even worse. Yeah. I'd take the 1 out though. That's maybe what I was doing. Wrong there. Okay. That's, wait, I can do, just set it to 0.5 because that'll be the high point of this. Yeah, I'm still having this problem. So I just did nothing here. I just did a whole bunch of nothing. How does that make sense though? Excuse me. Maybe 0.88. Maybe that's not right. No, that'll go to 0. No. Oh, did I do it? I think I did it. No, oh my god, the fucking knot. Sorry, the knot's not attached. Okay. Okay. This works. Okay, this, if I can just get it to go down. I don't need a piece of paper to draw this on. This is confusing. So I'll walk you through as I'm drawing this somewhere. Where are my notebooks? There we go. Okay. So sometimes when you're programming, you just gotta get out the pen and paper. So the first step is 0 to 1. This is self.shape. And then the next step is to multiply times 2 minus 1 to 1 and negative 1. And then we take the absolute value of that, and we get 1 to 1 with a dip in the middle. Okay. And the problem is we're going from 1 to 1.25 or whatever it is. 1.125, so 1 to 1.125, down to 1 again. And we just want to compensate for that in the other direction. So oh my god, I just need, no, I do need to, yeah, okay. So then 1.25, 1.25, yeah, but, okay, because it seems like, oh, maybe I'm doing something wrong here, okay. Oh, maybe I don't need to invert it. That's the problem. Because I want to go to 1 and then down to, how do I control where it goes down to? Yeah, so I multiply by the range, so that we have the range that we wanted to be going over, which is 0.125. So that's, okay, I'll draw that, times 0.125. And we have a little shallower v here. Yeah, 1 plus. Okay, but then do we want to invert this? Because we want to. Okay. Struggling with this a little bit. Because this is 0.125 at the edges, and 0 in the middle. Now that we've done that, oh yeah, okay, and then so 0, right? But no, that's, yeah, 1, 0.125 minus this, so is it 1 plus? What is this a value to? Okay, so if we do minus 0.125, then we get this thing where we are point between 0 minus this. 0. problem is you have to do times 1. You have to do R factor. Okay. Maybe this will work. Nope. Let's see. What does this look out? Okay, at least that's that. And then we're going to 1, 2, 6. That's because we're adding something. We're multiplying. We're going to divide. There. There it is. Yes, there we go. Okay. Yes, I did it. I did it. Hell yeah. Okay, hold on. Oh, but we need to adjust this a little bit because it's still going over 1 a little bit. That's okay. Oh, it might not be a linear curve. That's okay. Okay. What I'm going to do is actually going to add this with an input here, and I want to be able to gate this. So, okay. I want to be able to gate this with this clock very quickly. Gate. Faster to 100 because I want to see as I swing this knob, it's going to go up and then it should go down. So there's this a quarter turn is actually where it's the highest. Interesting. Okay. Okay, at least that's being kept below. So, 2.25. Let's do 3. So. Hold on, I'm putting here, so that plus 0.294, was it 0.0294? So let's do 0.3 just to, oops, 0.03. This might be a fool's errand, and I might not be able to do this because of the way that the shape is generated. What did I do there? Oh, I left that code in there. There we go. 5, 7. Let's do 5, 7. Let's do 5, 8. 5, 8. Okay. Let's just do 1.6. I don't think this is going to be audible, the difference between these. Oh my god, how is it? What the hell's going on here? It's getting smaller, but it's like receding towards something, and it's not actually. Let's just just crank it up to 2. That shouldn't. Okay, that works better for that, but then this is lower. That might just be the price I have to pay. It might just be the price I have to pay. Okay, let's do, how's it? So for this, 1-to-1. For 25%, 99, we lose a little bit there. So halfway, you lose a tiny bit there. But that shouldn't be so bad. And then we do 3/4. We're back close to there and to there. I'm fine with this. I'm fine with this. It keeps it. Let's do this again. We'll do 100 just to be sure. See, there we go. There was a little bit that it's going above. What the hell? Yeah. I know this is really finicky of me, but I don't want to be in a position where later this is causing a problem, it going outside of this range. But that's almost too much. It's 10% in the center. I'm gonna ask ChatGPT for advice. Let's see what's going on here. Does that keep it generally with it? I might be wrong. It might be. Yeah. Let's see what comes out of this. Yeah, but that's too much. That's too many multiplications, I think. Maybe that's okay. Oh my God. No, there's no way this is gonna work. I will be upset if this works. Yeah, see. ChatGPT is really bad at math. Yeah, of course. Okay. Screw you. Wait, what am I doing here? This do. It might not be so audible. I would love this to just stay constant, but I don't know if that's possible. It might just be the nature of it, but at least now it's not going above 1, so that's the most important thing. Okay. But I think there's a way to like simplify this math, because I don't want to do division either. What is that when you okay. X divided by 1.25, and then what is X. I think that's right. Multiplication factor. This is 0.75, right? Am I just making this way too complicated? Sometimes little things like this really trip me up. Python runs a fucking... Okay, the reciprocal. Yeah. I mean, that makes sense. It's like 20, I don't know. What the hell? Oh my God. I was staring at this the whole time. the hell is this doing here? I was just not even looking at this. Oh my god. What was I doing? Staring down my nose. Why was that there? Let's do it that. Maybe get rid of that glitching. See? What was I thinking? Ayoy. I just did this so stupidly. Let's do the times. I need to debug this R factor because I can't see it and that's driving me crazy. So let's do R factor. And then let's do debug right here. Math meter value output. Where's that saw? And then debug by this. Okay, so it is doing what I thought it was. Okay. BRB. This is working how I thought it would in the first place. Whoops. Back. Oh, God. I just want to... This is an old chat window that I had up, and I want to make sure that it's still... Just okay. Okay, that's updated. Okay, I did that from my phone. Okay. So why is this? This is weird. Why is it? It shouldn't be doing that. Okay. So R factor is 1. That makes sense. Sum times 1. And then do half. Doesn't make sense. Why that? That's weird. Oh wait. I did have that there for a reason. I did, yes, okay. That was there for a reason. Okay, let's do that. Okay, hold on. That was because when you double them, they halved. I think, right? Because when the waves get doubled, they go in half, and this was something that I added. Yes, I needed to do this because it was taking care of that. But I think I can do this now. I should be able to. No. What did I do? Because R factor is 0. No, I have an error. Times R factor and then R factor. There we go. Okay. Do I just, is there no way to get around? You have to divide by this? That doesn't make sense. The problem is, if I don't do this somehow, like then it's, minus R factor. Yeah, there we go. Okay. Because then we go up. Yeah. Okay. We're back on track. It's too low now, though, so I think we can lower this. This. Maybe this fixed it. Like I always thought would. Yes, that's much closer. Nope, we're going a little bit over there. Okay. 0.02326. Okay. So it is at that quarter turn that's the highest. Just so we can change this in one place. Equals so 1, 2, we'll sub this back out later, but while I'm experimenting, do this and go up and go down to the saw and do that. 4, 5, 6, 7, 8, 6, 7, 8. Okay, that's good. Okay. And to 1. Okay, so that works. Is that working for the whole swing? No! What the hell? Why is there this little bump like right in the beginning and then it goes down? That's so weird. 74. What is this value? I mean, I'm just wondering if this value is significant in a kind of like pi-like way or some multiple of something. So 474 is the biggest one. Okay. We're adjusting this f value here to 1, 2, 1, 5, 4. Okay, 2 and 4. Let's just paste that in there then. I can take this out. I want to avoid assigning variables as much as possible to save on CPU. Okay. Yeah. Oh my god. It's like it's pushing it. It's like it's pushing it down here. Like, why is this now 18? Out. Take the F and F out. So 2, 1, 6. Saw. Whoops, uh-oh. 5. 6. I kind of want to see the... I can't be sure that there isn't some tiny decimal out there, so if I see the 0.999, then I know that that's good. But then here again, it's getting pushed. It's getting pushed. 4. 5. They really... you really got me there. Okay. I gotta go all the way down to 1/4, so I'm losing a bunch of energy in the middle, but I don't know there's any way around this. This is what if you really need it, the pure sine is for. I'm gonna do an audio test and see how much this really dips in the middle. Okay. Let's see this. I'll put my headphones on. Did I lose the music from before? Oh no, I just turned the volume down. Hold on. Okay. I turned the volume down on my side. Okay, pause that. Let's turn headphones up. Headphones, okay. We'll do output. And while we're at it, let's just play a little. I'm going to take a from the VCO. I'm going to get this little, come on. this thing. And we're going to put that into the hertz value, and we're going to have a little sequencer here. Okay. Generator. Generator tile. And then let's do modulation octave. And another clock over here to generate some random values. And this should be enough. Should hear this. I need a what's it called? A what? Forbidden. That's funny. Okay, between these two. Okay, that's definitely louder. I can kind of feel it. Maybe that's just a side effect. I don't know. I might have to give up on this today. At the very least, it doesn't go above 1. And what I could do maybe is no, that's gone above. What's the inverse of that? Yeah, square root. This is a very expensive operation, but we'll just see if it makes a difference. It does. Oh, no. There we go. Oh wait, no. I should be doing dot square root of this thing. Oops. Out of shape. Like this. No, that's way too much. It's even more. Okay. Trying to shape this curve so that you can. Nope, it exceeds it there. Yeah. I might be able to change the F. Wait, I don't need a clock. What am I doing here? It's got its own internal clock. See, essentially it does an octave shift there because it's doubling the waveform there. Let's see how the triangle sounds just for fun. That's pretty juicy. Let's get an envelope here. I'm almost done for today. Don't know if I'll be able to solve this completely, so I might just move on. This could be something, a minor pull request that someone could do later on to fix this to be a little more accurate. Okay, so clock. Ah. There we go. Okay. Yeah, and of course we're aliasing a little bit here. I need to do a sampling. So we can do this. I don't need any memory. Let's do a really good color. Square wave. Where's that aliasing? Let me see if I can. What am I doing? So, inside of this, oh, I already have them there. I have a little downsample filter there. It's already better, but what we need to do is to super sample. Super sample. Where is it? I am blanking. It's on DSP, of course. Resample. And we'll sample this by 2. And what we do, the hertz. That's actually an interesting conundrum. Yeah, how would you get this to resample? See, that sounds a lot better. Actually, hear that tearing there. The shape actually might need to be updated every sample. Nope, I guess not. I'll have to figure out what to do about that later. You can definitely hear the difference there. At the edges of it, that's a lot better. Let's do 16. That's messed up. Oh, did I not do? Yeah, resample down to 1. Takes a lot of a lot more CPU. Is this simply just because it's like a slew limiter? Let's try this. Sounds like shit. Of course. There we go. That was the missing piece. That does sound a lot better. Yeah. We should do that because we are modulating the shape of the wave, and we don't want to kind of discontinuously do that. Let's try this. See, yep, and then same thing. We can't skip on this. It's got to be a resample. Okay. That sounds pretty good. We gotta go with 4. Sort of kind of like an attack to it, and then it goes a little longer down into the sound. Okay. Yeah, phase offset we definitely need to put. Phase offset on it. Everything that's a little weird. Okay, odd. Let's see how much. It's using 30%. Oh my god. You kidding me? Oh, that's because I was still doing this stuff. This goofy stuff over here. Okay. Getting to 7 o'clock. Gotta move on today. I think I will leave it out for here. Didn't quite solve this, but I will work on that, and hopefully we can do something more interesting tomorrow than just kind of scaling stuff. But that was interesting. We made the high-low detector. Oops. High-low detector. This is kind of a cool sound too. Alright, I think I'll call it there. That's a fun little patch. I could be tweaking this for a while, but let's just set this up a little nicer. Don't need that. Don't need these. That's kind of nice. A little high-low detector. Okay. I can't refuse putting a little echo on it. Or maybe reverb. Let's do reverb. Let's just play it. There you go. That's open. Okay, leave it at that. See you guys on the next stream. Bye-bye.